Okay, hi everyone. My name's Carly. I am a full stack engineer at a company called ZocDoc, which is in New York City. What ZocDoc does is we build a website and an application where patients and doctors can connect. So patients can schedule appointments or search for a new doctor or dentist. As it turns out, healthcare is pretty complicated, so it's only in the US right now. Sorry, but hopefully coming to Europe someday soon. But yeah, so we use React on the front end, we use Redux also, and ZocDoc has a really strong testing philosophy, and we have continuous integration running across all of our code bases. So I want to talk to you today about making backend devs jealous of your test suite. So first I'm going to start off with talking about sort of like the motivation for testing and why we should write tests in the first place. Then I'll talk about the tools at ZocDoc that we use and how to write some of these types of tests, and how to actually integrate these tools into your code base. And finally, I'll just leave off with a quick conclusion. OK, so the whole motivation and reason I sort of started getting interested in this topic was that we have a lot of full stack engineers at ZocDoc, which really means a lot of pretty back-end leaning engineers, which is great. They're all really, really good engineers. But I noticed that many of them, when they will take some front-end pieces of work, they'll kind of freak out and not really want to work on the front end, and yeah, it's not a great scene. So I started thinking about why that is, what could be, making the front end scarier to work on than the back end. And I think I came up with like two hypotheses for what that was. The first is CSS, which, I don't know how much we're really going to do about. It's definitely getting better over time, but it still can be difficult to work with. And the next is that it's really hard to tell if you broke anything when you make changes on the front end. When you write code for the front end, there's a really wide array of devices and browsers and applications and screen sizes that your code can run on, and it's impossible to go through and manually test all of these. So if you make one CSS change to a responsive component, it's really difficult to be sure that that's actually showing up correctly everywhere. You might be thinking right now that you don't need tests if you don't write bugs. But I want to just try and dispel that notion from the beginning. Tests are for much more than just catching the bugs that you are writing today. I like to say, save a dev, write a test. Oftentimes, these tests are for developers who are going to be working on your code 2, 3, even 5 years from now, and they need to be able to make changes to your code comfortably and be confident that they haven't completely broken stuff. Tests also are better than any README. They work better than most documentation that's out there. This is a little snippet of code from an XKCD comic, and it's a method called getRandomNumber that is hard-coded to return 4. And the comments next to it say that it's guaranteed to be random. So obviously, in this case, the documentation is wrong, and this is a bit of hyperbole. But if you had a unit test around this, it would serve as much better documentation than as these comments. Tests can also serve as a really good signal to refactor your code. There's nothing like a 50 or a 100-line setup method for your unit tests that tells you that it's time to split up your service. So it can just sort of be another tool to encourage you and let you know when it's time to introduce another level of abstraction. And finally, tests are just good for your company in general. Tests are the first step to setting up continuous integration, which is the first step to setting up continuous deployment, which is the first step to being able to deliver features faster, to fix bugs faster, and to serve your users better, and to make money at the end of the day. Cool, so that was a bunch of the sort of motivation for why we should write tests, or why I believe we should write tests. Now let's jump into how to test and how to use some of these tools. I'm going to walk through like tools that ZocDoc uses, but there are many options for a bunch of these kinds of tools. OK, so like I said, I'm from New York in America, and I've made a small little sample website for this talk. And I was trying to brainstorm the themes of what I would build for this talk, and I thought I could do something American, so I was trying to look at what funny stereotypes Europeans might have about Americans, and I came across this map, which I think is great. I think it's pretty accurate, actually. So I've decided to stick with this theme, and I made this little website called Cowboy Horoscope, where you can get your horoscope from the Cowboys. And it's really simple. All it does is you just enter in the month and day of your birthday, and then you can click this button, reveal your cowboy horoscope, and it will just tell you some little bit of wisdom to guide you on your day. All the code is available at this GitHub link. I'm also going to have a slide at the end with all the relevant links, so you don't have to worry about writing them down or anything. But the site's also up at cowboyhoroscope.com if you want to go and play with it and let me know how it's broken or what bugs there are, because I'm sure there are some. But yeah, so as we go through this talk, I'm going to use this sort of as an example for a bunch of test cases that we'll run through. Okay. So this is Martin Fowler's testing pyramid. It's really famous. Many of you guys have probably seen it before when talking about testing philosophy. It's meant to inform you of sort of the structure of your test suite. So it should begin with a really wide, broad base of unit tests at the bottom, which is your really supporting layer, and then gets smaller and smaller and fewer tests from there on up. And the reason I think it's structured this way is sort of because of the signal-to-noise ratio on the way up through the pyramid. So on a unit test level, you have really low noise. If your unit test is breaking, there's a really good chance that the code that you've written is actually impacting that break. As you move up the pyramid, you get less and less granular and on that level. You can have end-to-end tests breaking for a wide array of reasons, and they could be breaking for nothing to do with your changes. And so those are inevitably much more difficult to hunt down and diagnose and fix this flakiness. Whereas unit tests are much easier to deal with, so you always want to bias your test suite towards many unit tests. Okay, so for this talk, I'm going to walk us through each step of the pyramid. So I'll start out with unit testing, and I'm going to focus on some Jest concepts, but most of these high-level concepts apply to really any test runner, so it's still applicable even if you're using some other framework. So here's a sample unit test. This doesn't actually do anything, but it's just sort of to set a baseline for what we want our unit tests to look like. It should be extremely simple. Unit tests should be really isolated. They should test only one thing at a time. And ideally, you have just 3 lines in your unit test. One that sets something up, maybe mocks something out if you need that. One that actually calls the method or renders the component that you're hoping to test. And then one that actually verifies only one thing. So if your tests start looking really much larger or too different from this, you're probably not ready unit test anymore. You're probably closer to an integration test. Okay, so let's talk about testing this birthday form right here. It's from this Cowboy Horoscope website, and you simply enter in your month and day of your birthday, and you click this button to do something. So this select box is actually a third-party component. So I didn't write this select box. I downloaded it from NPM. And so when I'm writing a unit test, again, I want to only test one thing at a time. So if I'm actually rendering out that select box, that means I'm probably writing an integration test instead. And so I really want to be able to mock any dependencies in any children outside of the exact component I'm testing right now. So Airbnb made this really cool library enzyme. It's pretty famous. Many of you likely know it. And what it does is it allows you to only render the top-level children of your components. So it means in that select box we were talking about, when I look at the markup of the rendered form, I'm only going to see a stub for the select box, and I'm not going to see all of the markup that's included in it. So here's an example of using enzyme. It's this shallow method that you see on the first line. So what this test is doing is it's testing the birthday form, and it's going to make sure that it has 2 select boxes on it. It's going to shallow render it so that the select boxes are only rendered at the very top level, which is good. And then it's going to just check that there's 2 of them. So this test is fine. It's not really testing like real business logic that much. It seems to be testing some arbitrary DOM implementation. So it's not the best test in my opinion, but it's still fine. It probably won't be too flaky. What I notice with unit tests, though, is that they tend to grow to look something like this. So just take a second to read this test. So it looks like this test is setting some class on some icon somewhere on this website. And what it's going to do is first use this method called mount, which is actually going to fully render the component, including its dependencies. So that should already be an indication to you that you're writing an integration test and not a unit test, since you're actually relying on the dependencies. Then it's going to go and simulate some change on some input, it looks like, and then simulate another change on another input. It happens to be the second one on the page. And then it's going to find the first icon on the page and expect it to have a certain class name. So I think what this is doing is going and checking that March 12th selection results in a class name with PCs, or Pisces. So I usually grow to hate these tests. They usually flake out a lot. They are super tied, very coupled to my DOM implementation. So if I just happen to change the structure, add an input somewhere, they usually start failing, and that's pretty frustrating for me. I think that this is really an integration test, but it's written with the tools that in the debug abilities that you have for unit tests. So it's just, the tools aren't exactly built for that. So that's why I am going to make a really brief plug for Redux. And when I say Redux, I mean really any state management library. Of course, you might not need Redux. This is really famously said. A lot of people say this. And that's definitely true. Like maybe for your side project or your hobby project, you don't need Redux because it's small enough. But in that case, you probably don't really need that robust of a test suite either. So if you're writing enterprise-level code for companies and users that really rely on you, and you have to work with a lot of engineers in parallel, you probably need Redux or something similar to this, some state management library. And the reason why this helps for testing is that it forces you to separate, or it at least encourages you to separate your business logic from your markup. So all your business logic moves into things like reducers and actions and map state to props. And then your markup just moves into your component. So we don't have to do that sort of integration level testing that we were doing before. We can break it up into multiple different unit tests. So the test that we were talking about before can be broken up into one, which tests the markup. And this is a snapshot test, which we're going to talk a lot about later. This is also some jest functionality. And what this is doing is it's going to render this birthday form with some props passed in. And then it's going to just make sure that the markup of that birthday form doesn't change over time. So it's just going to compare it as we go a long time, every time you're in the test. And if it changes at all, it'll let you know. And if it doesn't, it will simply pass. Then the actual business logic section can be moved into testing map state to props. So for example, when we were selecting March 12th as the birthday, we can just set that as our state, hard code that. Then we can call the map states to props function and just verify the output of it. So in my opinion, these two tests are much easier to read, much easier to maintain, and much less likely to flake out than the sort of integration level tests that we were looking at before. Of course, it will result in you needing more total tests because you'll probably need some unit tests for your actions and for your reducer also. But again, remember this testing pyramid. We're happy with a broad base of unit tests that are really easy to maintain, read, and diagnose when they go wrong. So in my opinion, like 4 of these really maintainable unit tests are better than 1 difficult to read and maintain integration test. OK, so that was all I wanted to say for unit testing. And now I'm going to move on to component and integration level testing. I'm going to talk about snapshot testing specifically for this. I'm going to talk about sort of like the good parts, the bad parts, when it's working, when it's not. Then I'll present an alternative tool to use, and finally talk about how to actually integrate that into your code base. OK, so what is snapshot testing? I mentioned this earlier, but it's basically just a comparison of the output of something over time, every time you run the test. So quite traditionally, that's like rendered React components, and it's actually markup. But snapshot testing can work with plain old objects. It can work with a string, a value, really anything. It's very flexible. OK, so let's go through when snapshot testing is working well. Here's a really simple snapshot test. I'll let you read that. This one is actually taken from the jest documentation. All it's going to do is to render this really simple link component. It links to Instagram. And then it's going to make sure that the rendered version of that doesn't change over time. And if it does, it will alert you to it. So let's say we change it to Facebook instead of Instagram, right? Now we get an output that looks like this. So we really easily can see that Facebook has changed to Instagram, or reverse. And it's pretty easy to diagnose exactly what's changed. It's easy to understand and pinpoint what's going on. And if I'm happy with that change, if I purposefully made that change, I can go ahead and run this simple command to just use that new rendered output to compare against for future tests. So that's great. This is exactly how we want snapshot testing to work. It's really easy. It's simple. Now let's talk about when snapshot testing starts to break down a little bit. So here's another simple snapshot test. This one is going to render my cowboy horoscope page, and it's rendering this top-level app component. So it's pretty much the whole page. It's passing in some hard-coded props, and it's going to make sure it matches the snapshot. So let's say I wrap this in one additional div, which is something that you might do for a variety of reasons in real life. Now when I run this snapshot test, I should see like one new line at the top with the new div, and one new line at the bottom, closing that div. So yeah, let's go see the output. Okay, no, it is not one line. It's like many lines. It's like almost every line of the whole application. This is impossible to digest, this kind of output. It's obviously not really consumable by a human. If I have a test output like this, usually what I do is I go and look at the component with my own eyes, and then I say, merge to master. Yeah, like it's definitely overkill. If it were me using this test, I would either keep being really annoyed at the test and annoyed that it's muddying up my pull requests, or I would probably just delete the test entirely. Okay, so let's talk about an alternative to that kind of level of snapshot testing. ZocDoc actually tried to build an in-house solution for this at first, but it was working well, it was working fine, but it was, of course, like a lot of work to maintain, and obviously not our core competency. It's not our competitive advantage, so we looked to third parties, and we found this one called Percy, which has been working well for us so far. And what Percy does is it compares images of your rendered components. It's actual visual diffs instead of markup diffs. So here's a screenshot of Percy, and see if you guys can spot the difference. Yeah, so Percy will go ahead and highlight exactly what's changed in red, which is that the label for the select boxes as well as the placeholders have been shifted to the right. It's honestly something that I'm not sure I would catch by myself in real life. I can see myself making this mistake, but Percy would have caught it for us, which is great. So if you liked that change, if you meant to make it, you can go ahead and hit that approve button in the top corner, and now your new screenshot will be used to compare against for the future. Furthermore, Percy allows you to test a bunch of different screen sizes. So here I'm testing 320 and 1280, but you can add in more screen sizes if you want. And this is really a big win over what's usually a snapshot test, because those really didn't enable any kind of responsive testing whatsoever. And it's usually very tiresome to go and manually verify the state of your application in all these different screen sizes. So Percy helps a ton with that. So now that you sort of see what Percy does, I want to talk a little bit about how it works. And I think a really cool thing is that it does not work by uploading images to Percy. So you don't have to worry about creating some kind of screenshot taking utility, or even running the tests locally, really, or managing some repository of images or anything like that. It just accepts static HTML, CSS, and other page assets like fonts and icons, things like that. And because it accepts just HTML and CSS, it means that it integrates really well with a variety of frameworks. So notably today React, but it also works with Ember, Vue, WebDriver IO, as well as others. And you can always write your own. ZocDoc actually did some contribution for the React version for Percy. Okay, so now I'm going to talk about actually integrating Percy into your code base and what that feels like. So there's extremely easy integration with React Storybook. If you guys use Storybook, I definitely recommend trying this out. If you aren't familiar with the Storybook, here it is. It's basically a living component library of your React components. So right here we have a button component. This one is called a link button. And then you can set whatever props or children you want on your component in Storybook. So for example, here's the button with some emojis as the text instead. And to define these stories, it's pretty simple, actually. You use this method storiesof, and then you just go ahead and add a story case, I suppose, and render your component with whatever props or children you want. So if you already have this set up, then your stories just are your Percy snapshot tests. So it's that simple. So if you're already using Storybook, you should definitely try out Percy because it's so fast to integrate for you, and you don't even need to write additional test cases. There's also a React integration, which is similarly simple to get set up, but of course you need to write new test cases. So here is an example of a regular React integration test case without Storybook. And you just use this method, Percy snapshot, and you can pass in your component, and again, whatever props or children you want to have in the photo. So once you do that, if you set a couple environment variables on your local, like your login credentials for Percy, and you add a script to your package.json, then you can just run npm run Percy from your local machine, and you can actually go to Percy's dashboard and simply just look at whatever diffs are existing right now against your local code. So it's not even only a CI tool. It does also integrate with GitHub and your CI tools, though. So it can block merging until somebody approves those visual diffs. And it's also really convenient for code reviewers because what used to be a process of the person writing the code, going and taking a bunch of screenshots, copying and pasting them into the pull request, and then somebody looking at them, and not even being sure if that's the latest version of the code that's been committed, they can just click on the Percy diffs and go and browse exactly what all the components look like, what's changed, what looks the same, and so it helps a ton with that too. Percy also keeps track of who approves snapshots as time goes on, so if for some reason you're wondering who has mistakenly approved something, you can always go back and check that. Okay, so what's the catch? I've talked a lot about all the great things about Percy, but of course every technology has trade-offs. And the first is just to remember that it doesn't catch everything. So I'm not advocating that you run home and you delete all of your snapshot tests in favor of these Percy tests. Even the first example that we were talking about with a link where the href has changed, Percy wouldn't have caught that because it's really only testing what the page looks like and not how it works and what the actual markup is. So I would just consider snapshot tests in Percy to be essentially like two different layers of armor in your test suite and in your fight against bugs. The second is that it costs money. It's not a free tool like just snapshots are. So in my opinion, at ZocDoc, it's been well worth the investment, and they do have options for like open source communities and nonprofit organizations. So if you fall into those categories and are interested in it, you should definitely talk to them. They're really friendly. They can probably hook you up with some sort of scenario. But for regular enterprises, yeah, it costs money, but probably less money than your developers fixing all those bugs. Okay, great. So that was component and integration level testing. Now I'm going to move on to end-to-end testing. And before I jump into the tools and how to write these kinds of tests, I want to talk a little bit about end-to-end testing philosophy, which is that I like to view it as really the absolute last line of defense. End-to-end tests, usually like Selenium level, browser level testing, are difficult to set up locally, they're difficult to run, they're slow, they're annoying to write, they flake out a lot, they're harder to maintain, and there's just a wide array of reasons why you don't want to rely on them too much. So I like to kind of think of them as a goalie in soccer, in that if you're relying on your end-to-end test to catch many of your bugs or serve as your documentation, that usually means that some level of testing up the chain is failing earlier, which is similar to if you're a soccer goalie and your goalie's making all the saves, that probably means your defense is failing somehow else. At the same time, of course, nobody really wants to play a game of soccer without a goalie, so they're always nice to have. Yeah. So I'm going to talk about WebDriver I/O, but there are lots of options aside from WebDriver. I see it a lot in front-end applications, I think because it's in JavaScript and people have a lot of context in JavaScript when they're working on the front end. Here's a really simple sample WebDriver test. All this is going to do is open up a browser to my local host, check the title, and then make sure that the title equals Cowboy Horoscope. So this is a really simple end-to-end test. It's almost hard to say it's really end-to-end. But ideally, your tests are going to stay at this relatively small level of complexity, even in the end-to-end world. As soon as they start to get bigger, they start to get more difficult to maintain and flakier. And so think back to what that unit test looked like and still strive for this level of simplicity in your tests. So if you've ever had to maintain a Selenium bot suite on your own, you probably know it's a ton of work and it's really difficult and it's no fun for anyone. We have done that at ZocDoc for a long time, and we always have to have a full-time developer, at least one dedicated completely to it. It's a ton to maintain, and so as much as you can, I would encourage you to offload this kind of work to other companies, third parties. At ZocDoc, we use BrowserStack Automate for all of our front-end applications to run our end-to-end tests on those. However, they have some really good competitors, so I would definitely encourage checking out Sauce Labs. And then this other one, Cypress, which I don't know that much about, but they seem to be new to the scene and claim to be Selenium-less, which sounds pretty cool. So consider those too. One of my favorite features about BrowserStack is that they have video recordings of all of your end-to-end tests. So that means that you don't even really have to worry too much about running the tests locally. You don't have to make a video recording software or integrate with one at all, or manage a repository of videos or screenshots of failed tests or anything like that. As soon as a test fails or passes, you can just go to the BrowserStack dashboard and you can watch the video or download it if you wanted to download it for some reason. And you can also sort of step by step what commands were run at each time and what happened as a result of that. So like I was mentioning before, these tests are super flaky often and difficult to maintain, and so the fact that you have video recordings really helps to diagnose that stuff. BrowserStack Automate also has a really good capabilities generator, and so you can run your tests on a really wide range of devices and operating systems and browsers. So instead of just running this one test on Windows 10 on Firefox, because that's what your Selenium bot is set up to do, you can run it 20 times on all these different devices and operating systems. And so this helps a lot to reduce that kind of fear that I was getting at in the beginning of not knowing if you've actually broken something from making a change on the front end. It also lets you test at different screen sizes, so this helps with responsive testing too. So this is one line from a WebDriver config file, which is sort of how you set up your WebDriver configuration, of course. And in order to integrate that with BrowserStack, so to indicate that you want to actually have these end-to-end tests run on BrowserStack, they have a pretty simple integration. Mostly it's this one line that indicates to WebDriver that you should run it on BrowserStack, and then you need to add some credentials in some other places and some of those capabilities, that JSON that we were looking at earlier. But after that, like your CI system, I integrated with Travis for this example, should largely pick up that it should just automatically run on BrowserStack, and the results of the test will automatically be reported back to Travis. So that's actually pretty straightforward. Although I will say that setting up these kind of end-to-end tests is probably at least an order of magnitude more difficult than setting up unit testing and per se testing. So React Native, I haven't really mentioned React Native. ZocDoc does do some React Native actually, but we don't have really an end-to-end testing situation set up for it yet. BrowserStack has an option for that. They have BrowserStack App Automate, I believe, and I think that uses Appium. So if you're using React Native, definitely check that out. But I would also check out one called Detox, which I think is by Wix, which is supposed to be gray box testing and tries to solve a lot of the problems that people have with Appium. OK, so one more note on end-to-end testing, which is just that even though we're calling it end-to-end testing doesn't mean it necessarily has to be fully end-to-end testing. At ZocDoc, our front end is often completely separate from our back end, and it would be a ton of work in order to spin up our whole back end in our continuous integration system and run tests against it. So we don't really want to do that. And so what we do is we set up just a really small node server that runs right alongside our front-end application in our CI environment. And we just hard code all of our API contracts. So we make sure we have really solid API contracts with our back end. And then we can just hard code them right here. And then we're able to run our front-end Selenium testing without having to worry about spinning up an entire back end or clearing out databases every run or things like that. Okay, so that's what I want to talk about for end-to-end testing. Now just one brief note on exploratory testing, which I see this really as like manual QA. BrowserStack is even more famous for their live product, which is pretty cool. It's kind of what we were talking about before with how you can test on a bunch of different devices, a bunch of different browsers, but you can just hit whatever code is locally running on your computer. So you can just open up the BrowserStack website and tell it to go to localhost 3000, and it will go to the localhost that's hosted on your own computer right now. So you don't actually have to wait for the tests to fail to figure out that your CSS didn't work in Firefox or something like that. OK, so that was the testing pyramid. And now I'm just going to leave with a brief conclusion, which is that I think we're kind of in like what I see as a front-end renaissance right now, in that the number of frameworks and libraries that we're using are absolutely exploding, and our applications are becoming vastly more complex. Of course, they're also vastly more scalable and maintainable in the long run. So it's all for the better, but I think like in this time, we have a really strong responsibility to maintainability, and I'm really hoping that 5 years from now, we're not up here talking about our spaghetti React apps and how we've moved on to the next thing. I'm hoping that we've made robust enough tests, we've made isolated components, we've really built things in the right way to start, and that our developers working on your code in 5 years won't be too upset about it. Cool, so here's the relevant links for a bunch of the tools that I was talking about today. Posting the slides on my GitHub account, so you can always see them there. But yeah, feel free to snap a picture if you want. It's like, good. And also, I have this Google form for feedback. I'd love to hear your guys' thoughts on the talk. Yeah, please let me know what you think. And with that, thank you so much for your time. I work at ZocDoc in New York City, and we are obviously hiring, always hiring. It's a really fun city. Come talk to me if you're interested. But yeah, and also come talk to me if you just want to see demos on the Cowboy Horoscope website with any of these testing tools or anything.